All right, looking at floor plan dimensions and notes today. Chapter 17, you should have your book open to that page in your text, and we'll start looking at the basic principles of dimensioning in architecture. So, essentially, they provide measurements that are used for construction of the building, whatever it is. And of course, because that's what our primary goal is to build something from our drawings, then we find them on all types of architectural drawings. The dimensions that you put on your drawing are going to use, of course, various lines. They're all typically thin lines, like a 0.3 millimeter. And they have numerical values, they'll have symbols, and then notes and specifications of text also make that up as part of the dimensioning. So drawings must include all dimensions needed for construction. So when you look at your drawing and you're wondering, have I got all the dimensions on there? You have to put yourself in the place of the carpenter, the masonry person, the finish person, the installer of equipment. Put yourself in their place going out that day when your company is responsible for doing a certain amount of work or type of work on a building. Is there enough information there for me to do it if I am that person? There are there is only aligned dimensions used in architecture. Now in mechanical, which you all have done a fair amount of mechanical drawing, machine drawing, in learning how to do CAD or drafting, we use unidirectional a lot. So aligned dimensions in architecture is the only system that we use. Dimensions are placed in line with the dimension lines. So when you look at that page showing a detailed floor plan in your text, you can see your dimensions are aligned with the dimension line. Okay? And they read from the right hand of the drawing and from the bottom of the drawing. Okay, so they're horizontal and they're also turned 90 degrees and vertical, but readable from the right hand side. They never mix up. They're never readable from the left hand side. Okay, let's see. Extension lines show the extent of the dimension. That's pretty well established. Easy concept to understand. We place a small space from the feature being dimensioned and extend past the last dimension line. So let me zoom up on that page, see if I can. Okay, we can scoot around here and look. So there's a little gap always placed, and if there's some kind of round feature, CAD is notorious for when we select something round on a corner, that it, the extension line kind of blends into the radius for some reason, okay, because your connection point might be way down at the tangent. So always stretch or move your connection point of your extension line so that you have a gap. And usually it's about a 1/16 of an inch, real measurement. And then out this way, it's about an 1/8 of an inch beyond the dimension line. So looking at floor plan dimensions, the different pieces and parts. So you have dimension lines and extension lines, about a 1/16 of an inch gap. If it's an interior extension line, we use the center of the feature. Okay, so you'll actually, this is really office by office. You don't see this a whole lot where we actually use a center line for the center of a wall. It takes a little bit too much time to do, so you won't see it a whole lot. Now, on the other hand, you might see it more going to the center of a window, but not very much. So if you want to make these solid, make them all solid. Every center of a wall and every center of a window. If you decide to use center lines on yours, then if it's an interior wall or a window, then all of them that are centers need to be center lines. Okay, you can't mix it up. All right, now this exterior extension line is assumed to be the outside face of the studs or sheathing. Okay, and so you'll see that on figure 17.4 in your text. So let's take a peek at that. And zoom back out. So if you flip over to page 362 and you take a peek at that, and I sketched this out on the board last week, I believe, but you have a foundation wall, your sill plate, your joists, your rim joist it's called, that wraps around the building, your studs, your subfloor, so they all end up in line with the outside of the foundation wall. And then this double line right in here is called your sheathing. Big pieces of plywood, 4x8 sheets in a lot of cases, cover the whole structure with plywood on the outside, and it extends down past the sill plate, this piece of 2x8 or 2x6 that lays on top of the foundation wall. All right, then the siding attaches to that. So your exterior dimension line is to the edge of the foundation wall. All this material that extends out past there is going to be varied thickness. Okay, depends on where they buy it and what type of siding is being used, and it's just placed on the outside of the wall. So when we're drawing up our floor plan, this is the critical matching dimension. Okay, let's see what we got here. Sometimes some contractors, builders, like to set it in. It's not a good recommended practice. It allows for, you got to have a fair amount of flashing right here to prevent moisture and insect infestation. Okay, so not the best practice, but you might find this. All right, and this is on light commercial or residential. All right, now here's an example here using a center line. Okay, examples of types of terminations. Okay, so you can use a slash. Can be a, in this case they're talking about a freehand slash. That's if you're doing a sketch. There is a setting in AutoCAD where we can use this type, a bold looking slash, or a dot, or a standard arrow that's 1/8 of an inch long, or an open arrow, so closed in or open. Either one. All of these are acceptable. This, 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 or this. Okay. So, in a little bit greater detail, here's your face of the stud. You can see it's lining up